We're going to be graphing from the y is equal to mx plus b form. We call this the slope y-intercept method. Now, we don't have to graph using a table of values. This is another method that we could do it. In this method, we need to know what the slope is and we need to know the y-intercept. Then we're going to be plotting points based on those two things. So the first thing, identify the y-intercept and plot the point. So in this case, we have b is equal to -2. Now at -2, I'm going to put a dot. Second thing, we're going to identify the slope. Now remember, when we have the slope, there's two ways to write a slope. We could always write it with positives or we could write it with negatives. So in this case, it's very explicit that this is 3/4. But we know that if I have a -3 over -4, these two are equivalent because two negatives make a positive. Now, the reason I want to do that is because sometimes we want to be able to find the next point in both directions. So let's look at our first one, 3/4. I'm going to rise by 3 points, 1, 2, 3, and then I'm going to run by 4, 1, 2, 3, 4. I am unable to do the next one because it would be off this graph. So I'm going to go in the other direction, and this is when my other slope becomes important. I'm going to go down by 3 units, 1, 2, 3, and then I'm going to go across by 4, 1, 2, 3, 4. Now I have 3 points. I will join all 3 points. Remember to make an arrow at the end of the graph, and we can label our equation y is equal to 3/4x minus 2. So the key things that we did, we identified the slope, we identified the y-intercept. And because we were able to draw 3 points with it, we were able to connect it. Okay, so quick hint, remember to label the line with the equation and remember to draw arrows to show the line continues. Let's do 2 more of these questions. We have y is equal to -6/4x minus 3. First thing, I need to identify the y-intercept. So in this case, we have b is equal to -3. So at -3, I'm going to plot a point. Second thing we have is slope is equal to -6/4. Now, if I have -6/4, we know that the negative sign could either go on the top or the negative sign can go on the bottom. So each of these would give us two different ways of seeing things. Now let's say we decided to go with the first point. The first one gives us a -6. -6 is too far down. We won't be able to graph it. Let's use this other one, 6 and -4. We're going to go up and then to the left by 4. 1, 2, 3, 4, 5, 6, and then we're going to go across by 4. 1, 2, 3, 4. We've got 2 points, and we're probably unable to find a third because it would be off our graph. So let's just connect these 2 points. And we can label our equation. Y is equal to negative 6 over 4x minus 3. Now, one other thing that you could do, if you would like, you notice that 6 over 4 is a fraction that we can reduce. So because it's a fraction that we could reduce, we could say that this is equivalent to negative 3 over 2. So if I used negative 3 over 2, I would be able to plot a few more points on the graph. I would go down by 3. I'd go down 1, 2, 3, and across by 2. Or I could go up by 3 and across by 2. So you see that these are all points that are on this line. Okay, let's graph this equation now. Y is equal to 4x plus 5. Once again, let's start off with our y-intercept. B is equal to positive 5. We're going to plot positive 5. Next, we have our slope. In this case, slope is equal to 4. But remember, if I have a whole number, like a 4, I could always rewrite my whole number as a fraction by saying 4 over 1. I could also say that this is a negative 4 over a negative 1. So let's say we were to use our first one, positive 4 over positive 1. That would be off our graph, so not very helpful here. I'm going to use this one, negative 4 and negative 1. So 1, 2, 3, 4, across by 1, 1, 2, 3, 4, across by 1, and I could do it once more, just for good measure, and we have our line here. So the line y is equal to 4x plus 5. Pause the video and try these on your own. You can do all of these graphs on the same Cartesian plane, or you can make a different grid for each one. Now, sometimes you're given as the equation of a line in standard form. We need to first convert it to y is equal to mx plus b before we're able to use the slope y-intercept. So let's rearrange this equation. So our first equation, we have y is equal to negative x minus 6. The second equation is a little more involved. Negative 2y equals negative 3x plus 4. And then we're going to divide both sides by negative 2. So we have 3 over 2x minus 2. Okay, in our first one, we have y-intercept of negative 6 and a slope of negative 1. Let's start graphing at negative 1, at negative 6. So when I have a negative 1 slope, That means I could say I have a slope of -1 over +1, or I could say 1 over -1. I can use my first one, down 1 and to the right once, and then I'm going to use the other one to go the other direction. Up 1, across by 1, up 1, across by 1. You see the pattern. Okay, our line here is going to be y is equal to -x minus 6. Okay, our second line, we have our y-intercept of -2, and the slope is 3 over 2, or we could say it's -3 over -2. I'll use red for this one. Let's start at -2. We're going to rise 3 and run 2. 1, 2, 3, 1, 2. Rise 3 and run 2. We can do it a couple of times. And so we have a line that looks like this. Let's write the equation. Y is equal to 3 over 2x plus 4. Right, pause the video and try some of these on your own. Rearrange this into y is equal to mx plus b form, and then graph it first with the y-intercept and then